There's a bridge in China so high that the cars driving across it are literally above the clouds. Look down from the railing and you don't see a river. You see a blanket of white cloud, and somewhere far below it, hidden in shadow, a canyon floor so deep the sun barely reaches it. The road deck sits 565 meters above the water. That's the height of a 200-story building. It was the first bridge in human history to break the 500-meter barrier, and for nearly a decade, it held the title of the highest bridge on Earth. But the craziest part isn't the height. It's why they built it so absurdly high in the first place. Because the mountain itself was trying to swallow the bridge. Here's how they did it.
Now watch why anyone would build a bridge into the clouds.
Deep in southwestern China lies the province of Guizhou. It's stunningly beautiful, and it's a nightmare to travel through. The whole region is a maze of steep mountains and plunging canyons, the kind of terrain that traps people. For centuries, two towns could sit just a few kilometers apart across a gorge, but getting from one to the other meant a punishing, winding drive of hours. All the way down into the canyon, across the river, and back up the other side. Roads that flooded, roads that crumbled, roads that took forever. Guizhou is one of the poorest provinces in China, and a big reason was simple. The mountains cut everyone off from everyone else.
So China launched a colossal plan, a nearly 3,000-kilometer expressway slicing across the country, from the east coast all the way to the border with Myanmar.
And that highway had to punch straight through Guizhou's brutal mountains. To do that in a straight, fast, modern road, you can't keep diving down into every canyon. You have to leap across them. And one of those canyons, the Beipanjiang River Gorge, was so wide and so deep that crossing it would require building the highest bridge the world had ever seen. Here's the core engineering problem, and it's a big one. This isn't a wide, gentle valley. It's a savage gash in the earth. Steep limestone cliffs dropping hundreds of meters straight down to a river. You have to fling a road across a gap this enormous, hundreds of meters up in the open air.
I'm right on the edge of this sheer cliff, where the wind is fierce and the drop is lethal. And you can't put a single support pillar down in the middle of that gorge. It's far too deep.
The entire crossing has to leap from one cliff to the other in essentially one great span, held up from above. Now the numbers. The bridge deck sits 565 meters above the river, the height of a 200-floor skyscraper. The whole structure is about 1,300 meters long. The main span, the gap it leaps in one go, is 720 meters, one of the longest spans of its kind in the world. And to hold that up, it uses two towers, the tallest around 269 meters. That alone is one of the tallest bridge towers ever built, taller than most skyscrapers. On paper, madness. All they had to do was build it.
So let's start with the strangest fact of all. The reason this bridge is so ridiculously high. You'd assume they built it 500 meters up because the canyon is just that deep.
But that's only half the story. The real culprit is the rock itself. This region is what geologists call karst, a landscape of soft limestone that's riddled with hidden caves, cracks, and sinkholes. It's like Swiss cheese underground, and you cannot anchor the towers of the world's highest bridge on top of a hidden cave, or the whole thing could collapse into the earth. So as the engineers surveyed the cliffs, every time they hit unstable, hollow rock, they had to move the bridge. And again, and again. Chasing solid ground, they kept pushing the crossing higher and higher up the canyon walls.
Until they finally found rock strong enough to trust. The bridge isn't 500 meters high because they wanted a record. It's that high because the mountain kept refusing to hold it until they reached the level where it finally would.
Once they found their footing, they had to build the towers, two enormous H-shaped concrete towers rising from the cliffs, among the tallest bridge towers on the planet. And these aren't just decoration. In a cable-stayed bridge, these towers are everything. Every bit of the deck's weight, plus the cars, plus the wind, is funneled up through cables into these towers and down into the bedrock. They are the shoulders carrying the entire cross. Building towers this tall on the edge of a sheer cliff in a remote mountain region with almost no flat ground to work on was a feat by itself. And that remoteness was a monster of its own.
This is not a normal construction site. We're in a gorge, deep in the mountains, miles from civilization. There are no proper roads here.
Before they could build the bridge, crews had to carve access roads into the mountainsides just to get trucks, steel, concrete, and workers to the cliffs. And to move heavy materials across the gorge during construction, from one side to the other, over that 500-meter drop, they strung cableways across the canyon, like giant zip lines hauling bridge parts through the air. Just getting the pieces to where they needed to be was an engineering challenge before a single deck section went up. Everything about this location fought them. Now the real magic. How you get a road across a 700-meter gap with nothing underneath to support it.
The answer is the cable stay design. From the top of each tower, dozens of high-strength steel cables fan out and down, and they hold the road deck suspended in the air.
Think of it like a hand holding a plank flat, by lots of strings attached along its length. The load is spread across all those cables evenly, which lets the bridge span an enormous distance with no pillars in the middle. But there's a catch. The tension in every single cable has to be tuned just right. Too much or too little tension in any one of them, and the deck warps. You'd get a wavy, uneven bridge. Getting all those cables balanced perfectly is a delicate, precise art. And here comes the part that seems physically impossible. How do you actually build the deck out across the gorge when there's a 500-meter drop beneath it and no way to hold it up from below? You can't build scaffolding up from a canyon floor that far down.
So they build the bridge outward from both towers at the same time into empty air. They add one segment of steel deck, then immediately hang it from a new cable up to the tower.
They add one segment of steel deck, then immediately hang it from a new cable up to the tower, then the next segment and another cable, then the next. The bridge grows out from each side, segment by segment, each new piece held up by its cable the instant it's added, reaching further and further out over the void, until the two halves, built from opposite cliffs, finally meet in the middle, hundreds of meters above the clouds. And that meeting is the most nerve-wracking moment of the entire project. Two teams, starting from opposite sides of a canyon, building blind toward each other across a 700-meter gap, hundreds of meters up. If the two halves don't line up almost perfectly, they won't join.
The engineers reportedly had a margin of only about 5 millimeters to work with. 5 millimeters across a bridge more than a kilometer long, built from two separate cliffs.
When the final deck section dropped into place and the two halves became one continuous road, it was a triumph of almost unbelievable precision. But the bridge's true enemy, up at that height, is invisible. Wind. 500 meters up, in an open canyon that funnels and accelerates the air, the wind is relentless and violent. And a long, thin bridge deck hanging in that wind is in real danger. If the wind catches it just right, the deck can start to sway and twist, and that motion can build on itself until it tears the structure apart. Famous bridges have been destroyed exactly this way. So the deck here is a steel truss, an open latticework of triangles, incredibly strong and stiff, but with gaps that let the wind blow through it instead of slamming into a solid wall. The bridge is shaped to survive the sky it hangs in. And when it was finished, the achievement was so respected that the team behind it won what's often called the Nobel Prize of Bridge Building, a top international award for engineering. This wasn't just a big bridge. It was recognized as one of the most impressive feats of bridge engineering anywhere in the world. It's worth pausing on how this compares to the West's most famous bridge in the clouds, the Millau Viaduct in France, opened in 2004, a graceful cable-stayed crossing whose tallest mast still stands as the tallest bridge structure in the world. Millau is genuinely stunning, and its towers are taller. But there's a key difference. Millau is tall because it marches across a wide, open valley on a row of slender piers, like a series of masts. The Beipanjiang Bridge is different. It's not about the towers being tall, it's about the deck being high, flung across one deep gorge in a single enormous leap. Millau strides across a valley. Beipanjiang leaps a chasm. Both are masterpieces. They just solve very different landscapes.
Now step back and look at the bigger picture, because it's genuinely staggering that one bridge taller than about 120 meters. China had exactly one bridge, our home to widest bridge in 150 meters.
In a single generation, China went from having almost no high bridges to utterly dominating the record books. Guizhou, once trapped by its mountains, became the high bridge capital of the world, a place engineers now call a bridge museum. And China's hunger for records didn't stop here. For nearly a decade, the Beipanjiang Bridge reigned as the world's highest. But in 2025, it was finally dethroned, not by another country, but by China again, on the very same river. Just a couple hundred kilometers downstream, engineers finished the Huajiang Grand Canyon Bridge, whose deck sits even higher above the water. China beat its own record on its own river. The world's highest bridge is now a title that changes hands within a single Chinese province, as each new crossing pushes a little further into the sky. And here's what all of it is really for. It's easy to see a bridge like this as just a jaw-dropping spectacle. But for the people who live here, it's transformation. That crossing that used to take 4 or 5 hours of white-knuckle mountain driving now takes barely 1. A child can get to a better school. a farmer can get crops to a real market before they spoil. Medicine, jobs, trade, family, all of it suddenly flows across a gap that used to cut people off. The world's highest bridge isn't a monument. It's a lifeline flung across the sky. And imagine actually driving it. On a clear day, the view is dizzying. You glance out the window and there's simply nothing beside you but open air and distant mountaintops. The river a thin thread far, far below. But on many days, the gorge fills with cloud and mist, and something surreal happens. You drive across the bridge and can't see the bottom at all. There's just white below the railings, like the road is floating on top of the sky. Drivers describe it as crossing into another world for a few seconds. A strip of asphalt suspended in the clouds, cliffs vanishing into fog on either end. For a structure built purely for function, it delivers one of the most otherworldly drives on the planet.
Here's the bottom line. To build a bridge above the clouds, engineers didn't spot the mountain itself, which kept crumble beneath them until they were hover-shield cables in the infra cables in and out in one enormous leap, and let the clouds roll home. That kind of story we break down here. See you at the next impossible structure.